Hello everyone, this is Ajay and you are welcome on my YouTube channel, which is Math Cafe. So this one is the part 10 of the topic matrix, and this video is all about adjoint of a matrix. Alright, so let's proceed. So we will say that if A is given to us, that A is a square matrix. A is a square matrix, because we will define adjoint for only square matrices. Then adjoint of A will be transpose of cofactor matrix of given matrix. Alright, then adjoint of A will be transpose of cofactor matrix of given matrix. Alright, so if let's say A is given to us A11, A12, A21 and A22. So this is 2 cross 2 square matrix. So we will find adjoint for this matrix. So adjoint of A abbreviately is represented by ADJ, adjoint of A. Alright, so adjoint of A is nothing but transpose of cofactor matrix of given matrix. So transpose of cofactor matrix. So we will write cofactors of each of elements. So cofactor of C11 is A11 is C11, and cofactor of A12 is C12, and cofactor of A21 is C21, and cofactor of A22 is C22. So we will take transpose of this cofactor matrix. This will be called adjoint of A. Alright, hope you understand this. Let's take an example here. If A is given to us 1, 2, 0, minus 1. Alright, and we need to find adjoint of A. Alright, this is simple. We will just find cofactor corresponding to each elements. So C11, let's find C11 minus of 1, and C12 will be minus of 2, that is minus 2, and C21 will be minus of 0, that is 0, and C22 will be plus of 1, that is 1. Okay, so finally adjoint of A will be transpose of cofactor matrix. So cofactor matrix is minus 1, C12 is minus 2, C21 is 0, and C22 is 1. We will take transpose. Alright, so finally adjoint of A will become minus 1, minus 2, 0 and 1. Alright, we will just change all the rows and columns. So adjoint of A will be this. Hope you understand this. So let's move to the another example here. Let's say if any matrix A is given to us, let's say 1, 2, 0, 3, 4, 0 and 1, 6, minus 1. Alright, and we need to find adjoint of A. Okay, let's proceed. So first of all, we will find cofactors corresponding to each element. So C11 will be 4, 0, 6, minus 1, that is equal to minus 4, and C12 will be minus of, so we will delete row and column corresponding to 3, so we will be left with 2, 0, 6, minus 1, that is nothing but minus of minus 2 minus 0, that will become 2. Alright, C13, so plus 1, so 2, 0, 4, 0, that is 0 minus 0, finally we will get 0. Alright, so just like that we will find C21. So C21 is nothing but, so we will delete row and column 3, 1, 0, minus 1, so 3, 1, 0, minus 1. Alright, 3, 1, 0, minus 1. Alright, so finally we will get minus of, that is 3. C22 will be C22 corresponding to this element Alright, so 1 0 1 minus 1, 1 0 1 minus 1. So finally this value is minus 1. Alright, we'll find C23. So C23 negative of, so for C23 minor will be 1300, 1300. So finally this will be equal to 0, and C31 will be equal to C31, cofactor corresponding to 0, so C31 3146, 3146, that is nothing but 18 minus 4, that is 14. Alright, let's find C32. So for C32 we will take minus, so C32 cofactor corresponding to this element, so we will get 1126, 1126. So finally we will get value of this 6 minus 2, that is nothing but minus 4, and the final C33 is 1324 plus 1324, 1324. Alright, so this is nothing but 4 minus 6 is equal to minus 2. Alright, so we have obtained all the values of cofactors corresponding to each elements. Finally we will get transpose matrix of cofactors. So finally adjoint of A will be C11. So C11 is nothing but minus 4, 2 and 0, minus 4, 2 and 0. Alright, and C21, C22, C23 is 3 minus 1 0, 3 minus 1 0, and finally C31 is 14 minus 4 minus 2, 14 minus 4 minus 2. We will take transpose of this matrix, that will be adjoint of A. So finally adjoint of A will be minus 4, 2, 0, 3 minus 1 0, 14 minus 4 minus 2. Alright, this is our final answer. So now we will look at some properties here. Okay, based on adjoint of matrix. So first property is, if A multiplied by adjoint of A, that will be equal to adjoint of A multiplied by A, and that will be equal to mod of A multiplied by I. Alright, this is important property. Alright, so let's proof of this property. It is given in this property, A multiplied by adjoint of A will be adjoint of A multiplied by A, and determinant of A multiplied by I. Alright, let's take an example. If I is A11, A12, A21, A22, this is square matrix of order 2. Alright, and we will find adjoint of this matrix as C11, C12, C21 and C22. Alright, and we will multiply A by adjoint of A. So finally we will get A11, A12, A21, A22 multiplied by C11, C12, C21 and C22. Alright, so we will multiply these two matrices by row column multiplication. Alright, so finally A11, C11, A12, C12, that is nothing but determinant of A. Alright, and A11, C21, A12, C22, that is 0. A21, C11, A22, C12, that is 0, and A21, C21, A22, C22, that is determinant of A. Alright, so we will take common determinant of A, that is 1 0 0 1, and that is nothing but an identity matrix. So here we have proved that A multiplied by adjoint of A is determinant of A multiplied by I. Alright, let's see here second property. So here second property is determinant value of adjoint of A will be determinant of n minus 1, where n is order of the matrix A, where n is order of matrix A. Alright, this property is also essential. Alright, so we will just see proof of this property. Okay, so as we know that A multiplied by adjoint of A, that is determinant of A into my I, we have already proved in part first, that is point number 1. Alright, so we will take determinant value on both sides. So here determinant of A multiplied by adjoint of A, that is nothing but determinant value of I. Okay, so finally we can separate both the terms. So determinant of A multiplied by determinant of adjoint of A, that is equal to, I can take this determinant of A outside of this determinant. So finally determinant of A power n, n is order of matrix, so determinant A power n and determinant of I. As we know determinant of I is 1, so finally determinant of A multiplied by determinant of adjoint of A, that is determinant of A power n. So finally determinant of adjoint of A will be determinant of A power n minus 1. Alright, okay, let's see the third property here. So here third property is determinant value of adjoint of A is equal to determinant value of n minus 1 whole square. Alright, this property is also essential. So let's see proof of this matrix. Here also n is order of matrix A. Alright, let's see proof of this property. As we know that adjoint of determinant value of adjoint of A is nothing but determinant power n minus 1. Alright, so in this equation we will put A as adjoint of A. So finally we will get adjoint of A is adjoint of A, that is equal to adjoint of A determinant value power n minus 1. Determinant of adjoint of A is determinant of A power n minus 1, so that is determinant of A power n minus 1 and whole power n minus 1. So finally this will become determinant of A power n minus 1 square. Alright, so hope you understand this. Just like that, if it is written determinant value of adjoint of A. Alright, so let's observe here, if there is one adjoint in determinant, so value will be determinant of A power n minus 1. Alright, if there are two adjoint under determinant, so final value will be determinant of A power n minus 1 square. So if there is three determinants, then final value will be determinant of A power n minus 1 whole cube. Alright, so just like that, if there are four determinants, then final value will be determinant of A power n minus 1 whole power 4. Hope you understand this. Let's move to the property number 5, that is adjoint of AB is equal to adjoint of B multiplied by adjoint of A. Alright, this is also essential property. So let's see proof of this property. To prove property number 5, we will take this equation only and we will show both the terms equal, both the sides equal. Alright, so adjoint of AB is adjoint of B multiplied by adjoint of A. Alright, if I pre-multiplied AB on both sides, so here if I pre-multiplied AB on both sides, so finally left side expression will become AB multiplied by adjoint of AB, that is equal to AB multiplied by adjoint of B multiplied by adjoint of A. Alright, so here AB multiplied by adjoint of AB, that is nothing but determinant value of AB into my I, alright, is equal to, so B into my adjoint of AB, so A is as it is, and B into my adjoint of AB will become determinant of B multiplied by I and adjoint of A. So finally determinant of B multiplied by I, so A into my I will become A, so determinant of B multiplied by A multiplied by adjoint of A. So finally we know that A into my adjoint of A, that will become determinant of A into my I. So finally I can write it as determinant of A, determinant of B into my I. So that is nothing but determinant of AB multiplied by I. So in the left hand side the expression is determinant of AB into my I. So both the sides are equal, so this is proved. Alright, let's see another property here, property number 6, that is adjoint of A transpose is equal to adjoint of A whole transpose. Alright, so this is also essential property. Let's see proof of this property number 6. To prove this property number 6, we again pick this equation and we will show both sides equal. So adjoint of A transpose is equal to adjoint of A whole transpose. So we will pre-multiply it by A power t on both sides. So pre-multiply by A power t on both sides. So what we will get here, A transpose multiplied by adjoint of A transpose, that is equal to A transpose multiplied by adjoint of A whole transpose. Alright, so that is nothing but determinant value of A transpose multiplied by I, that is equal to, we can merge both the terms as adjoint of A multiplied by A whole transpose. Alright, so that is this is nothing but determinant value of A multiplied by I whole transpose. Alright, so I can take determinant of A outside, so this is nothing but determinant of A I transpose, and I transpose is I. So in the left hand term, as we know that A transpose, determinant value of A transpose and determinant value of A is equal, so determinant value of A into my I, so both the sides are equal. So this is proof of this property number 6. Let's move to the property number 7. So property number 7 is adjoint of A raised to n is equal to adjoint of A whole power n. Alright, okay, so let's see proof of this property here. This expression is written adjoint of A power n. So A power n is nothing but A is multiplied by A n times, so A multiplied by A multiplied by A n times. Alright, so by the property number 5 I can write adjoint of A. So we will start from back side, so adjoint of A will be multiplied by adjoint of A will be multiplied by adjoint of A, so this process goes on n times. Okay, so finally we will get adjoint of A whole raised to n. So adjoint of A raised to n is nothing but adjoint of A whole raised to n. Hope you understand this. Move to the property number 8. So here property number 8 is adjoint of Ka, that is equal to K times of n minus 1 adjoint of A. Alright, K is any non-zero constant. So here n is order of matrix A, order of matrix A. Alright, so let's see the ninth property, adjoint of A, that is nothing but determinant A power n minus 2 multiplied by A. Okay, here also n is order of matrix, here also n is order of matrix. Let's see proof of this property number 9. So here, as we know that A multiplied by adjoint of A, as we know that A multiplied by adjoint of A is determinant value of A multiplied by I. So here if I put A as adjoint of A, alright, so we will get here adjoint of A multiplied by adjoint of A is adjoint of A. So here determinant value of adjoint of A multiplied by I. So if I pre-multiply by A on both sides, so pre-multiply by matrix A on both sides. Okay, so finally we will get here A multiplied by adjoint of A, okay, and adjoint of A, that is equal to A multiplied by adjoint of A multiplied by I. Alright, so here A multiplied by adjoint of A is determinant of value of A multiplied by I and multiplied by adjoint of A, that is equal to, if A is multiplied by I, that will become A. Alright, and adjoint of A is nothing but determinant value of adjoint of A is determinant A power n minus 1. Alright, so here this is nothing but determinant value of A multiplied by adjoint of A is equal to determinant A power n minus 1 multiplied by A. So if I take determinant value in right hand side, so this will become adjoint of A is equal to determinant A power n minus 2 multiplied by A. So that is what we needed to prove. Now let's see here some examples. So example number 1 is, if it is given A multiplied by adjoint of A is, let's say 10 0 0 10. Okay, so we need to find the determinant value of A. So let's proceed with the solution. So here A multiplied by adjoint of A is nothing but, if I take 10 common from this matrix, this will become 1 0 0 1. Alright, so A multiplied by adjoint of A will be 10 times of this is I. Okay, so as we know that A multiplied by adjoint of A is nothing but determinant value of A into I. Okay, so if I compare both the terms, then we get that 10 is equal to determinant value of A. So here determinant value of A will be 10. Hope you understand this. Let's move to the another example here. So next question is given to us, if A is 1 2 0 2 3 0 3 4 2. Alright, then we need to find adjoint of A. Alright, so let's proceed with solution. Alright, as we know that adjoint of A is nothing but determinant A power n minus 2 multiplied by A. Alright, so where n is order of matrix, so here as we know that n is 3, so this expression will become determinant A power 3 minus 2 is 1, determinant A power 1 multiplied by A. Alright, so we will find the value of determinant A, so that will become, if I expand this around about row number 1, so plus minus plus, so plus 1 that will be multiplied by 3 into 2 6 minus 0, minus 2 that will be multiplied by 2 into 2 minus 0, so 4 minus 0, and finally plus 3 that will be multiplied by 0 minus 0. Alright, so we will get the value 6 minus 8 plus 0. So finally determinant value of A is minus 2. So determinant value of A is minus 2. Alright, So finally adjoint of A will become determinant value of A multiplied by A, so minus 2A. Alright, 1 2 0 2 3 0 and 3 4 2. That is our final answer. Hope you understand this. Let's move to the another example here. If it is given to us that matrix A is 1 0 2 minus 1 2 1 1 minus 3 0. All right, if B is adjoint of A, all right, and C is 5 times of A, C is 5 times of A, then we need to find expression of determinant value of adjoint of B divided by determinant value of C. We need to find value of this expression. All right, so let's proceed with the solution. So first of all, we will find value of adjoint of, so adjoint of B will be equal to adjoint of B is nothing but adjoint of A. All right, so as we know that adjoint are 2 times, so final value will be determinant A power n minus 1 whole square. All right, so here n is determinant order of matrix, so order of matrix is 3. So finally if I put n is 3, then this will become 3 minus 1 2 2 2 4. All right, so this is adjoint of B, and we will find the value of mod of C, that is determinant of C. So determinant of C will become determinant value of 5A. All right, and I take 5 outside of the determinant, so this will become 5 raised to n, and n is 3. Order of this matrix A is 3, that is determinant value of A. So that is nothing but 125 determinant value of A. All right, so finally we put all the values in this, so we will get adjoint of B determinant divided by determinant C. So determinant of adjoint B is nothing but determinant value power 4 divided by determinant value of C is 125 determinant value of A. So finally we will get determinant value of A power 3 divided by 125. So our job is to find determinant value of A. So let's find the determinant value of A here. So determinant value of A is nothing but, if I expand this along R1, so this is nothing but 1 multiplied by 0 plus 3, and minus of minus 1 multiplied by 0 plus 6, and finally plus 1 will be multiplied by 0 minus 4. So we will get 3 plus 6, 3 plus 6 minus 4, 9 minus 4, that is nothing but 5. So finally we have determinant value A as 5. So this is nothing but 5 cube divided by 125. So this is nothing but 125 divided by 125. Final answer will be 1. All right, hope you understand this. So if you still have any doubt, you may ask in the comment section. So see you soon in the next video. Till then, bye, take care and keep learning.